Hello everyone, welcome to our LLM4AD tutorial. In this video, we will show you how to design effective algorithms for traveling salesman problem using our LLM4AD platform. First, let us formulate the TSP problem. Let's start by looking at the diagram on the left. So each circle here represents a city, which we call the node, and the line segment here represents a possible route that connecting two cities. And the challenge is to help a salesman plan the shortest route that can traverse all the nodes on the map. Okay, let's see how TSP is formulated. So we will get a distance matrix as the input, and the objective is to minimize the road traveled by the salesman. The constraint is that the starting node is randomly selected. All cities should be hit only once, and finally we must go back to the starting node at the end of the traverse. Okay, we have already known that the TSP problem is an NP-hard problem, which means we cannot explore every possible route to find the best one, especially there are a lot of cities. Therefore, we can come up with a simple idea. We design a heuristic algorithm. So instead of looking for the perfect route, this algorithm decides step by step which city to visit in the next step. For example, if we are the current city, the algorithm can guide the salesman to move to the nearest city or the furthest city. To make this work, the code of the algorithm at least takes three inputs. The first one is a distance matrix, which tells us the distance between cities. The second one is the ID of the current city. And the third one is a list of unvisited cities, so we got to know where we can go next. And the output of the function simply returns the ID of the next city to visit. So once we have the input and output of the algorithm, we can get help from the LLM4AD platform to help design a better select next node algorithm. In the third step, we should measure the performance score of an algorithm. So here is a simple idea. So we will let the algorithm repeatedly decide the next city to visit until it completes a full route that visits all the cities and returns to the starting point. So once we have the route, we calculate the total distance traveled. So the total distance becomes the key metric to evaluate the algorithm's performance, which means the shorter the total distance, the better the algorithm. Okay, in this video, I will show you a code implementation for using the LLM4AD platform to solve TSP problem. Okay, first step, you should create a Python environment and install all these requirements. First, we are going to create a Python environment using Conda. Here we use Python 3.10 version. Then we activate the environment. And we install the packages used in this tutorial. So first step, we need to create a template program for an algorithm that include a Python packages and the name of the functions, arguments, and the typing of the return values, and some informations in the docstring, and a simple implementation of the function. Okay, let's run the Jupyter notebook together. The second step, we should provide an evaluation interface. So for your convenience, we have provided functions to produce datasets and calculate the distance for an algorithm. So the usage is provided in these two cells. In the LLM4AD platform, we should a complete following step to build an evaluator. The first step is to extend the evaluation interface, and the second step is to pathing the template program, the task description, and some useful parameters to the superclass. Okay, and the third step is to override the evaluate program function. Here is a tips for debugging. So first we create an evaluator and wrap it with the secure evaluator. Okay, and we invoke the evaluated program record time function and to see if it really works. Okay, there's no bugs. The third step, we need to provide an LLM interface which defines how we can access to the LLM. So the following cell shows an example for using an API to curate remote LLMs. And to test if the API is really work, we can invoke the draw sample function to see how it responds. Okay, we have installed these packages before, so we skip the step. In the last step, we create a profiler that can record and visualize the result. And we initialize the search method and pass these things to the method. So, and we can run the method. If you want to visualize the TensorBoard logs, you can execute this. Oh, sorry. Okay, and we can see the best score and some statistics, like the number of legal functions and illegal functions. Thanks for watching, and some useful links are provided here.